Welcome to another deep dive. This time, we're going to be checking out YuLan-Mini. It's a 2.42 billion parameter language model. And the thing that makes it so interesting is how incredibly data efficient it is.
Yeah, data efficiency is a big one with these models.
Absolutely.
So you've sent over some research papers on it, and I think we should definitely unpack why it's causing so much excitement.
Yeah, this model is like a David amongst Goliaths.
Yeah.
It's achieving amazing results with like way less training data than you might expect.
So pre-training, it's super important for building those like basic capabilities for language models,
Right.
but it can be such a resource hog.
Definitely.
It's massive data sets, it's, tons of processing time. And then there's the challenge of just like keeping the training stable. It's a delicate balance.
Yeah, so the creators of YuLan-Mini, they came at this problem from three different angles.
Mm.
So first of all, they made what they call a smart data pipeline, which basically means they blended different types of data really carefully.
I like that. Smart data pipeline.
Yeah, so, things like web pages, code, math problems, and even like synthetically generated reasoning examples.
Oh, wow.
And they use this technique called warm-up stabilization decay, or WSD scheduling.
It's like a dance.
Yeah, it is. They split the training into distinct phases, so it's like a carefully choreographed dance.
That's a great analogy. But another challenge with these big language models, training them can lead to a lot of instability.
Yeah, for sure.
Like you can have sudden drops in performance or like the whole thing just fails.
Right.
So to deal with that, YuLan-Mini uses a few things. First, there's scaled initialization, which basically lays the groundwork for a stable training process.
Mm.
Then you've got maximal update parameterization, or P.
Okay, I'm following you.
So that adjusts the hyperparameters as the model grows, kind of like how a marathon runner would slowly increase their mileage over time.
I see.
And then there's the WeSAR reparameterization method,
Wow.
which really smooths out the training process and helps avoid those like jarring swings that can throw everything off.
That's really cool. And they also added this thing called an annealing stage, right?
Yes, annealing.
Which uses techniques like gradient-based data selection to fine-tune the model with super high-quality data. And they even threw in challenging math reasoning problems and what they call slow thinking data.
Oh, slow thinking data.
Interesting. Yeah, basically forces the model to tackle problems that need like more deliberate thought process.
I see.
And then, of course, being able to process long sequences of text is super important if you want to understand complex ideas, right?
Critical.
So YuLan-Mini is designed to handle that. It can process up to 28,672 tokens.
It's way longer than a lot of other models.
Yeah, and they did that by tweaking the base frequency of rho p. That's the technique that helps the model keep track of where words are in a long sequence.
Clever.
So let's talk about how it stacks up against the competition.
Okay.
YuLan-Mini's actually done amazingly well in benchmark tests for math and coding tasks.
No kidding.
It's beaten out tons of other small language models, especially on tests like Math 500, GSN 8K, Human Evals, and MBPP.
That's really impressive.
Yeah.
So the makeup of YuLan-Mini's training data, it's not like set in stone. It actually changes throughout the different phases of the curriculum.
That's fascinating.
Yeah, the researchers, they carefully adjusted the mix of data based on perplexity measures. That basically tells you how well the model predicts what words are coming next.
I see.
They also tweaked it based on how well the model did on specific benchmark tests.
So it's a constantly evolving process.
Exactly. This adaptive approach seems to be a big part of why YuLan-Mini is so successful overall.
So we've covered the basic design of YuLan-Mini and how well it performs. But now I think it's time to dig a little deeper into the technical side of things.
Let's do it.
Like, how did they actually build this thing?
Well, training stability, it's a huge hurdle when you're dealing with large language models.
Right.
And the researchers who developed YuLan-Mini, they had to overcome some pretty tricky obstacles.
So, like, what were the red flags? How did they know they were running into problems?
It's kind of like navigating through a really complex landscape.
Yeah.
You're constantly watching the model's performance for any sign of trouble. The researchers were super meticulous about tracking three main things: loss, gradient, and hidden states. Loss is the most obvious one. It tells you if something's wrong, but it doesn't really tell you why.
Right.
But gradients and hidden states, those give you a much deeper look into how the model is actually working.
So what were those deeper clues telling them? What were they seeing?
They found that even tiny little abnormalities in the data could cause major instability, like a tiny pebble triggering a landslide.
Wow.
They also noticed that the hidden states, which are basically the outputs from different parts of the model, they were becoming more and more variable over time. And that could lead to those dreaded loss spikes and training failures.
So they had this hidden states issue. What do they do about it?
They came up with a multi-pronged approach. They combined a bunch of different techniques to stabilize the training.
Okay, I'm intrigued. Tell me more about these techniques.
So first, they started with scaled initialization. That's where you use scaling factors to make sure the model's parameters are set up in a way that encourages stability from the get-go. It's like setting the stage for a really smooth performance.
Gotcha.
And then they use something called maximal update parameterization, or P for short.
Okay.
This technique basically adjusts the hyperparameters as the model gets bigger, so it helps make sure the training stays stable even as the model grows.
So they're basically building a tougher training regimen that can handle the demands of bigger models.
That's a great way to put it. And to make things even more stable, they introduced the WESAR reparameterization method.
What does that do?
Well, it basically helps to separate the strengths of the gradient updates from their direction, so it prevents those sudden jerky movements that can cause instability.
That makes sense. So they use a whole bunch of stabilization techniques. Did they try anything else?
Oh yeah, they explored all kinds of things. Warm-up-based methods, module-based methods, numerical optimization techniques, you name it. They really left no stone unturned.
It sounds like they were incredibly thorough.
Absolutely. Their whole approach to developing YuLan-Mini was extremely meticulous. They wanted to make sure they achieved both data efficiency and training stability. And speaking of meticulous approaches, we have to talk about the data pipeline.
The data itself, right? Let's dive into that.
Yeah.
What can you tell us about the data they used to train this model?
Well, they were super careful about how they chose and prepared the data.
Makes sense.
Their goal was to have a training data set that was really high quality, diverse, and relevant to what they wanted YuLan-Mini to be able to do. It's kind of like putting together a team of expert trainers, each with their own specialized knowledge.
Okay, I like that analogy. So who are these expert trainers for YuLan-Mini?
They pulled information from all over the place. Web pages, code repositories, math stuff, general knowledge bases, and even synthetically generated data.
Wow, that's a pretty diverse mix.
Yeah, it created a really rich learning environment for the model by combining real-world and carefully crafted data.
So it sounds like they had a specific plan for the data. What were the main steps involved in preparing it?
Data filtering was a huge part of it. They had some really strict cleaning processes to get rid of any low-quality or irrelevant information. They wanted to make sure the model was only focusing on the most useful training material.
Yeah, it makes sense to give the model the best possible examples to learn from.
Right, and then they used something called topic-based text recall. They trained classifiers to pick out documents that were related to specific topics like math, code, and reasoning. It's like having librarians curating the perfect collection of books for each training session.
So they were guiding the model toward the most relevant information for developing specific skills.
Precisely. They also used model-based quality scoring. That means they used specialized models to figure out how valuable and how difficult each data source was. Kind of like having a panel of judges rating the quality of each training example.
Wow, so each piece of data was scrutinized.
They wanted to make sure everything was top-notch. And to avoid bias, they made sure the training data wasn't leaning too heavily on any one benchmark or data set. They even went through a decontamination process to remove any overlap between the training data and the benchmarks they were going to use for evaluation.
That makes sense. You want to make sure you're getting a fair and unbiased assessment of what the model can actually do.
Exactly. Now, you mentioned synthetic generation of reasoning data earlier.
Yeah, I'm curious about that. Can you tell me more?
Well, a lot of real-world data sets don't have enough examples of complex reasoning.
I see.
But that's a really important skill for language models to have. So to fill in the gaps, they actually created synthetic data samples that were specifically designed to show different thought processes and chains of reasoning. It's like giving the model a crash course in logic and critical thinking.
So they were training the model to think like a problem solver.
That's the idea. And they focused on a few key areas like math reasoning, code reasoning, and scientific reasoning. They even generated data that encouraged the model to think about its own thinking and figure out where it might be going wrong.
That's pretty meta.
Right. And to make the training even better, they used something called data mix.
Okay.
They carefully blended all these different types of data throughout the training process to create a well-rounded learning experience for the model. It's like a balanced diet. You want to make sure the model gets all the nutrients it needs to grow and develop.
That's a great way to think about it.
And of course, they also used data curriculum. They organized the training data so that it gradually got harder.
So they started with the basics and then slowly introduced more challenging concepts.
Right. They even used quality classifiers to figure out how difficult each data source was so they could adjust the curriculum accordingly. It was a highly tailored approach.
I'm really starting to appreciate just how much art goes into training a successful language model.
It really is an art. It's not just about stuffing the model with data. It's about carefully crafting a learning experience that helps it reach its full potential.
And one of the final steps in this journey is the annealing process.
Yeah, annealing is key.
It sounds like a crucial step in creating a powerful language model. Can you explain what it actually involves?
So annealing is all about refining the model's performance. It's like taking a finely crafted sword and putting it through this intense heating and cooling process to make it even stronger and more durable.
That's a vivid image.
During annealing, the researchers used a very specific optimization strategy. They started with learning rate annealing, which basically means gradually decreasing the learning rate over time.
Okay.
And that helps the model zero in on a set of parameters that work really well.
It's like fine-tuning an engine for maximum performance.
That's a great analogy. They also tackled the challenge of context window extension,
That's it.
making the model able to process longer chunks of text.
Wow.
That's super important if you wanted to understand complex stories or arguments. They did this by adjusting the base frequency of row P.
Oh, right. The thing that helps the model track word positions in a long sequence.
Exactly. And that allowed them to expand the context window from 4,096 tokens all the way up to 28,672 tokens.
That's a huge jump.
Yeah, it means the model got much better at understanding how ideas connect over longer stretches of language.
So what else did they do during the annealing process?
Well, they made sure to prioritize those high-quality data sources, especially the ones with lots of reasoning examples. They even used gradient-based data selection to pick out the most valuable training examples. And of course, there was the long context training where they exposed the model to those extended sequences of text.
Right, to help it develop that deeper understanding of how ideas flow together.
Exactly. And they also used a special packing strategy for the instruction data.
Okay, what was that for?
So when you're training on question-answer pairs, you don't want the model to just learn the answer. You want it to learn the reasoning behind the answer.
Makes sense.
So this packing strategy helps prevent the model from losing sight of the reasoning process.
So they were really nurturing those higher-level reasoning skills during the annealing process.
That's the idea. And finally, they did something called checkpoint merging.
Checkpoint merging.
It's where they combine the best-performing checkpoints from the annealing stage to create the final model.
It sounds like they really have a knack for refining and optimizing every single aspect of the training process.
They definitely do. Their dedication and expertise really shines through in how they developed YuLan-Mini.
It's been amazing to see the behind-the-scenes details of how this model came to be. We've learned about the challenges they faced, their innovative solutions, and the rigorous process they used to evaluate its performance. But our deep dive isn't over yet. There's still so much more to explore.
Let's keep going. Okay, so let's talk about how they actually evaluated YuLan-Mini.
Yeah, how did they put it to the test?
Well, the researchers wanted to make sure the evaluation was fair and really thorough. So they picked a bunch of different benchmarks to test it on like a whole range of skills and knowledge areas.
So what were some of those benchmarks?
Well, they used a mix of like really well-known and respected benchmarks covering all sorts of tasks and difficulty levels. For language comprehension, they used things like MMLU, Lambda, RACE, CMLU, and CVOL. For code generation, they used HumanEval and MBPP. For math reasoning, there was GSM-8K and Math 500.
Okay.
Then for logical reasoning, there was RRCE and RRCC. For common sense reasoning, they used Winograd, HelloSwag, and StoryClose. And finally, for long context understanding, they used Ruler.
Sounds like they covered all the bases.
They really did. And they even included benchmarks in both English and Chinese, which shows that the model can handle multiple languages.
That's cool.
And to make sure the comparison was fair, they picked other models that had similar numbers of parameters.
So it was like an apples-to-apples comparison?
Exactly. They included a mini CPM 2.4b, Quen 2 1.5b, Quen 2.5 0.5b, Quen 2.5 1.5b, Gemma 2 2.6b, Stable MM2 1.7b, Small MM2 1.7b, and Llama 3.23b.
So those were like the top performers in the world of small language models?
Pretty much.
Can you tell us a bit more about how they set up the evaluation? Like, did they use any special tricks or settings for the prompts?
Well, they tried to keep things as fair and consistent as possible across all the models and benchmarks. For some of the tasks like Lambda, Human Eval, MBPP, Race, Story Close, and Ruler, they used what's called a zero-shot setting.
Zero shot. What's that?
It means the model had to figure out the task without being given any examples or guidance beforehand.
Oh, wow. So it was like a cold test.
Exactly. But for the other tests, they used a few-shot setting where they gave the model a small number of examples to help it understand what it was supposed to do.
So they gave it a little bit of a head start.
Yeah, just a little nudge in the right direction. They used 4 shots for GSM-8K and math, 5 shots for MLU, CMMLU, Wanna Grande, and CVOL, 10 shots for HeliSwag, and 25 shots for RDE and RCC.
And did they use any other special techniques?
For GSM-8K and math, they use something called chain of thought prompting or COPE prompting. It's where you guide the model to think step by step and break down the problem into smaller chunks.
So they basically gave the model a set of thinking tools.
That's a good way to put it. And they also made sure to choose the right evaluation metrics for each benchmark.
Okay, so what were some of those metrics?
Well, for tasks where the model had to answer questions, they use things like MAJ at 1, pass at 1, and accuracy. For multiple choice questions, they mostly used accuracy, but for ARCE and RCC, they used normalized accuracy.
I'm guessing there's a reason for that.
Yeah, normalized accuracy takes into account the fact that some questions might be harder than others.
I see.
And to be extra sure about the results, they even used GPT-4o-Mini to double-check the answers that all the models came up with for Math 500.
Wow, they really went above and beyond to make sure the evaluation was rigorous and fair.
They really did. They wanted to make sure the result accurately reflected what the models were capable of.
So now for the big question. How did YuLan-Mini actually perform?
Well, the results were honestly pretty amazing, especially considering how data efficient this model is. It did incredibly well compared to other models of a similar size, even beating out some models that were trained on way more data.
It's a testament to how effective their training methods were.
Definitely. And YuLan-Mini was especially good at the math and coding benchmarks. It got some of the highest scores on Math 500, GSM-8K, Human Eval, and MBPP.
I'm not surprised given how much attention they paid to those areas during training.
Right, like all that work they did with the synthetically generated reasoning data, it really paid off.
It's like they gave the model a secret weapon, the power of logic and strategic thinking.
Yeah, exactly. But YuLan-Mini wasn't just good at those specialized tasks. It also did well on the general language benchmarks, which shows that it's a pretty versatile model.
That's really impressive.
And that's probably thanks to their smart data mixture and the way they adjusted the curriculum as the model learned. They basically gave it a really well-rounded education, exposing it to a wide variety of tasks and knowledge domains.
It's like building a strong foundation in general language understanding, which then allows the model to excel in more specialized areas.
Right. Now, it's important to point out that the research paper did mention some limitations with YuLan-Mini.
Okay, what were those?
Well, it didn't do quite as well on the ruler benchmark, which is all about understanding long contexts. Its performance there wasn't as strong as some of the bigger language models.
That makes sense.
Yeah, it's understandable considering they had limited computing resources and they couldn't expose the model to as much long context training data.
So it's a trade-off. You gain data efficiency, but you might sacrifice some performance in certain areas.
Exactly. But overall, the results are super promising. It shows that you can get amazing results with data-efficient training methods, which opens up all kinds of new possibilities for developing powerful AI tools without needing massive amounts of data.
Now, to really appreciate YuLan-Mini's journey, I think it's important to understand how the researchers kept track of its progress throughout the whole training process.
Yeah, that's a really good point. It's like a long and complex expedition. You need to keep a close eye on how things are going and make adjustments along the way.
Absolutely. So how did they actually go about evaluating the model's performance during training?
Well, they were super meticulous about it. They used all sorts of techniques to monitor YuLan-Mini's performance and make sure the training was on track.
What were some of those techniques?
Well, a lot of the standard benchmarks, they rely on things like the model being able to follow instructions, which is something that usually develops later in the training process. So if you only use those benchmarks in the early stages, you might not get a good sense of how well the model is actually doing.
It's like judging a marathon runner based on their first few steps.
Exactly. So they came up with a two-pronged approach. In the early stages, they focused on perplexity measures.
Perplexity.
It's basically a way of measuring how well the model predicts what words are going to come next. And it's a pretty good indicator of how well the model understands language in general.
So it's like checking the model's pulse to make sure it's healthy and learning properly.
That's a great way to put it. And to make those perplexity measurements even more meaningful, they created 4 different validation sets. One for English understanding, one for Chinese understanding, one for code generation, and one for math reasoning.
I see.
They were really careful about picking samples from a variety of sources to represent those key areas that they wanted YuLan-Mini to be good at.
It's like giving the model mini exams throughout the training process to see how it's doing in each subject.
That's a great analogy.
Hmm.
And then as the model got more mature and developed more advanced skills, they started to shift towards evaluating its performance on specific benchmarks. They focused on tasks like human evil and GSM 8K, which gave them a more direct way to assess how well the model could solve complex problems.
It's like watching the marathon runner pick up the pace as they gain strength and stamina.
That's a perfect way to describe it. And they kept a close eye on how the model was doing on those benchmarks, making changes to the training data and the curriculum as needed.
It sounds like they were really responsive to what they were seeing in the data.
Yeah, they were constantly tweaking things to help the model reach its full potential, and all that hard work really paid off. YuLan-Mini ended up doing incredibly well on a wide range of benchmarks, which just goes to show how dedicated the researchers were to creating a high-quality language model.
Okay, so we've really gone deep into the design of YuLan-Mini, all the challenges of training a language model to be so data efficient. And of course, those amazing results they got. We've seen how well it does with math and coding, how well-rounded it is with general language tasks, and even its limitations with long context understanding.
And we've gotten a much better appreciation for how careful the researchers were in tracking and evaluating the model's progress throughout the whole training process.
So as we wrap up this deep dive, what are the biggest takeaways here? What makes YuLan-Mini really stand out in the world of language models?
I think YuLan-Mini is like a shining example of what data efficiency can look like. It shows that you can get incredible results even with smaller language models as long as you train them in a smart way, and you don't need nearly as much data as those giant models everyone's talking about. And that's huge. It means we can start making these powerful AI tools more accessible and sustainable for everyone.
That's a really important point. It's not just about making bigger and bigger models, it's about making them smarter.
Right. And YuLan-Mini also shows just how important it is to choose and prepare your data carefully.
The researchers were super deliberate about that.
They were. They focused on quality, diversity, and relevance. They wanted to give the model a rich and balanced learning experience.
And one more thing that really stood out to me was how much emphasis they put on monitoring and evaluating the model throughout training.
That's crucial.
They were constantly checking on the model's progress, making adjustments as needed. And that kind of dynamic approach is what allowed YuLan-Mini to reach its full potential.
It's like being a coach. You're constantly observing your athletes, giving them feedback, and making adjustments to their training plan to help them perform at their best.
I love that analogy. So YuLan-Mini is really a glimpse into what's possible with AI. It suggests that we can create powerful language models that are both effective and efficient.
It's an exciting time to be in this field for sure.
Well, this has been a fantastic deep dive into the world of data-efficient language models. Thanks for joining us.
It's been a pleasure.